You made it to the session about migrations, which something tells me you care about that or currently working on a migration. A few years ago, I found myself in a room full of executives at a company called Lyft, which at the time was undergoing outstanding growth. And because of that growth, we had to migrate our warehouse to a more scalable data lake. And at the time, I was young and ambitious data engineer, and I volunteered to lead the architecture for that migration process. And so I'm sitting in this room with probably like a few VPs, VP of growth, just like, pretty high up stakeholders that I don't really talk to. And unfortunately, I have nothing good to report to them because they were expecting an update on how the migration is going, and it's been over 9 months, and unfortunately, there is pretty much no tangible progress in that amount of time. We haven't even migrated the most important table that we had at the company called dimension rides, which describes every ride that Lyft delivers. So no progress, and I am pretty much the one that everyone points to. So not a fun meeting, and one thing that I appreciated, that I learned to appreciate about senior stakeholders is they're not super technical, but they ask good kind of meta-level questions, like what went wrong and what may be wrong with the process, or how are we doing these things, and what have we learned in those 9 months? Okay, we haven't migrated anything, but at least have we learned something? And indeed, we have learned something. I have learned something, which is I made 2 major mistakes running this migration. One was around the process, and 2 was around tools. And ultimately, a project like that comes down to process and tools, and I failed to implement both correctly. So today, I'm excited to tell you about some of these hard-earned lessons about what are the major things to get right in terms of the process and how the most recent advances in technology can help us on the tooling side to accelerate migrations. So let's get started. So I'm Gleb. I am CEO and co-founder of Datafold. As you already learned, in my previous life, I was a data engineer, got to build some cool data platforms. And now we're building a data quality platform for data teams. So we'll talk about some common stuff just to kind of set the context, types of migrations, how to define success for a migration project, what are the major challenges and best practices to overcome those challenges, and the most exciting piece of all, how can we automate migration with the latest tech? So migrations are hard. They're not fun. They pretty much always go over budget and over time, but they're necessary, right? So you are in this room because likely you are about to or doing a migration, and you're doing this because this prevents your business from fully leveraging the data. So there are multiple types of migrations, right? We can be moving from a legacy warehouse to a new warehouse. We could be moving from a legacy framework to a new framework like dbt. We could be doing everything in the same time, plus also migrating BI tools. So who is here doing a data warehouse migration? OK. Who is migrating to dbt? Who is doing both at the same time? All right. OK. Hardcore people. Great. So what are the key challenges to migration? And I think that some of you already learned something. Maybe I'm not going to break any news, but still, I think it's helpful to set this as a framework so we can talk about how we overcome those challenges. So in my experience, a few things. One, large amount of data. The migration that I led, we had about 2 petabytes of data, which is not uncommon these days, but still a lot. High complexity. This was a few years ago when 500 models seemed like a lot for a company like Lyft, but these days we're seeing even startups, Series A, Series B startups, having thousands of dbt models. So the complexity now is even greater, I would say, thanks to how easy it is to build with modern tools. But the thing that it really screws you up is the dependencies, right? The amount of dependencies that business has on the data in the legacy platform. So for us, by the time we started the migration, we had over 20,000 reports, mostly in mode, that were querying the legacy warehouse. So just to be able to untangle that set of dependencies is quite a bit of work. Then there's a technical challenge, right? When we're migrating, things are different. So we're dealing with different dialects, different patterns. If we're moving from something like stored procedures to dbt, we also have to educate our team and our stakeholders. And data migrations are very expensive projects for organizations. One, just the sheer amount of time it takes someone to do the migration. And that's the direct cost. But the thing that is also very important to pay attention to that many teams don't think, and I certainly haven't thought when starting, is the indirect cost. So first of all, it's infrastructure. While you're doing migration, you're basically paying for two sets of infrastructures or two sets of vendors. You have to maintain two sets of technologies. You're probably missing SLAs because, well, you're doing a migration because the old system is already kind of not really supporting them. It's a mess, so you're not as productive, you're constantly distracted, your team is distracted. But the biggest thing is the opportunity cost. While you're doing the migration, you're not really spending time and attention building what your business needs in full power, right? You're essentially dealing with technical debt, and business stakeholders they can't really touch this. We know the difference between working with a legacy stack and the modern stack as data practitioners, but people who consume data, especially business stakeholders, they don't always know that, but they know that you don't deliver what they want. And so getting migration done as fast as possible is obviously good. It's good for us, it's good for the business. So let's talk about do's and don'ts. So I said that I made two big mistakes. One was around the process, and one was the lack of tools. So let's talk about the process first. The biggest question process-wise that you have to answer when going for migration is, do you do lift and shift, or do you re-architect? So lift and shift means we take all the code base that we had on a legacy system, and we do absolutely minimal effort to translate it to the new system. Carrying over technical debt, those spaghetti code, bad data model, bad naming, everything. But just like move it over. Re-architecting means that we're actually solving a lot of technical debt as we go. So who is doing lift and shift? Who is re-architecting? Interesting. OK. So I chose to re-architect because by the time we started the migration, Lift's data model was worked on by a ton of people. And it was built when the company was like less than 100 people. And while we were doing migration, we were 1,000. So a lot of things have changed. So I was like, this is finally the time for us to build a really good canonical data model. I bought myself a Kimball book, all those slowly changing dimensions, yeah? OK. So why re-architect? Obviously, getting rid of technical debt, right? We don't like spaghetti code. We don't like bad patterns. And potentially also getting better performance, because there's a lot of things that on the modern warehouse, on a system like dbt, if you really follow best practices, you can get much better performance and cost. The cons, though, so the biggest thing that got me was the need to drive the consensus with the business. Because the moment you start re-architecting things, you're likely changing naming here and there, model here and there, and you're doing this to improve your data quality, to improve your data. But better means different, and different means that you have to convince the business that now they have to deal with a new way of doing things, which is very hard, and it gets very hard at the larger company is. And so I, instead of actually doing the migration, spend most of my time in meeting rooms trying to convince different teams across verticals like marketing and finance that they have to adopt a new data model and new definitions. And they were more accurate. No one argued with that, but no one wanted to shift because that meant that numbers were different as well. And that didn't land well with business. So it's more work. And because of number one and number two, we can't effectively outsource the migration. So we can't just hire a consulting firm and have them do the migration for us, because if we're re-architecting, not only they have to do the work, they have to also learn how the business works and how it works now, how the data model changes, and they are even less effective than our team internally in doing the migration. And you also cannot automate effectively, because if you're re-architecting, well, it just requires a ton of manual intervention. So I learned the hard way that Re-architecting means fixing all technical debt. But if you really want to complete migration on time and on budget, you should do lift and shift. And that doesn't mean that you're just carrying over the technical debt forever. You can always deal with this later. So once you move to Databricks or Snowflake and dbt, you have all the time to actually fix the things that you need to fix. But you're not doing this as part of the migration project. And also, there's a lot of other benefits of doing this after, because you have a better developer experience, and you're not under this pressure from the business to finalize the migration, so you can kind of churn away all the technical debt later. But my big advice is always lift and shift. Those of you who disagree, I'm curious to learn more about your thinking and how it goes. So before we talk about the tools, let's talk about the success. So what does success look like for a migration? That's a simple question, but getting it very clearly answered for yourself and for the business stakeholders is very important. Ultimately, we do migration to get from old system to new system. So probably we succeeded when the old system is turned off. We turn off that Oracle, or we kill MicroStrategy, whatever. To do this, we need the business to adopt the new system. To get the business to adopt the new system, we need them to trust it. And for them to trust it requires us proving that there is parity between what we had in the legacy with what we have in the new. And if there's no parity, we are in the same problem as the architecture. It increases the scope, and we need to drive the consensus. And so again, aim for parity, because trying to improve things means they are different. Different means slow, and slow is bad for migrations. And optimize for speed. OK, so this is the process. Probably the biggest takeaway that I would like you to take from the session, process-wise, is doing things in the lift and shift manner. But let's talk about technology. So talked about the challenges with translating the code. Obviously, we can use a SQL translator or transpiler to convert from one dialect to another. And it's also not as straightforward, because a lot of times we're not just translating things one for one, even if we're doing lift and shift, but if we're moving from something like stored procedures, when one procedure builds 3 tables and also makes an update and a bunch of other things, we need to kind of entangle that, unpack it, and move it over to probably 3 dbt models, even if we're doing lift and shift. So leveraging the translators and transpilers is not always straightforward. But another thing that is really important for automation is the reconciliation. We talked about how success means parity, and reaching parity means understanding the discrepancies between the legacy data and the new data. And in my experience, and also we did a survey recently on LinkedIn asking people where do they spend most of their time, it was that in the reconciliation phase where people felt like they were mostly spending their time doing a migration. So what can you do to accelerate that part? Well, turns out there's a lot of problems, because, well, we're dealing with a large scale. We need the details. It's not just about comparing counts. It's also about comparing metrics, individual values. We also, a lot of times, have to do this comparison across different databases. So if your legacy in the SQL Server and then you stack is on Snowflake or Databricks, you have to be able to do this comparison across databases, which is harder. And we also need to not only compare it for ourselves, but also to communicate it to our stakeholders, which means our tooling needs to be able to support our workflow, but also be understandable by someone who may not know everything about every single table. So this is how you can solve this. So this is kind of a typical diagram. Like we have the legacy stack here, raw data translated into derived data, and the new stack, let's say we translate it's on Snowflake or Databricks or anything, translating on dbt, getting derived data here. So basically, we want to compare legacy data with the new data. And you can do this with a tool that we built called DataDiff. Essentially, it allows you to compare data sets within the same database, so across databases at scale. And it gives you both high-level statistical summary, but the magic comes from being able to drill it into individual values. And within database, it's kind of simple. We're just spitting out a bunch of SQL queries. But across databases actually requires a lot of algorithmic work because you can't just extract all the data and compare it a lot of times because you have a lot of data. So you have to be very clever how you checksum the data and identify discrepancies. But the cool thing is you get the interface that you can use a data engineer, but you can also scale to your consulting partners, stakeholders. Everyone can collaborate and see how fast you're progressing with the migration. So that's where the bulk of automation comes from: code translation and reconciliation. But the biggest unlock here, where the AI keyword comes in, is in our ability to take those two things together and bring them in the same cohesive experience. So introducing data migration agents. So what's an agent? It's just some kind of LLM-enabled thing that does some part of job semi-autonomously. And in this case, it does the migration for you. And the way that it does the migration for you is very simple. It takes legacy code, right? We're taking legacy code, let's say store procedures on SQL Server. We translate it using an LLM. We get the new code. And by the way, because we're using an LLM, it can spit out pretty much any code that you want. So you say, I want store procedures into dbt, fine, or Airflow, DAG into dbt, cool. Snowflake, any dialect, any framework, everything is possible. But that's not enough because models can hallucinate, and how do you know that it spits out correct code? That's where the data diff comes in. So once you have the new code, then we're running it in a new warehouse, materializing it, and then we are comparing it with the legacy data that you already have. And we're getting the data diff. And if we find any errors or discrepancies, we're feeding this back into the translator so it can fix those discrepancies. And we repeat this over and over and over again until we reach full parity. And if you look at this, you're like, well, Gleb, this is pretty much my workflow right now, which is exactly the point. The point is to take the workflow of a data engineer doing a migration and automate it in a way which is completely scalable. So migrations that would take years can now take weeks. And the interesting thing is, what is the interface to that, right? So if you're using our tool, Datafold, for this, how to interface with this. And the cool thing is you don't really interface with it. Basically, Datafold connects to your legacy database, new database, code base, ingests everything, and then does this migration in a pretty much a black box manner. You don't need to do anything. Obviously, this works for lift and shift. If you say, well, I also want to do things in a particular way, some of these things can be accommodated. But if you also want to change the definitions for all of your key performance indicators, well, then this approach wouldn't work as well. But for lift and shift, this works perfectly. So a project that we're actually wrapping this week is with a company called Sapdesk. It's an accounting firm in Germany, and they are doing a migration from Redshift and dbt to Snowflake and dbt. About 600 models, and also have a strict requirement for GDPR compliance because they're based in Europe. And so we were able to translate all models in about 2 weeks. And the rough estimate that we talked with them and agreed on is if they were to do it manually, it probably would take them about 2,500 hours, 4 hours per model roughly. And that means that the migration timeline is accelerated from 6+ months to just a few weeks. Obviously, as the complexity grows, the time grows as well. But in any case, in my experience doing a migration that took about 3+ years, being able to condense this into weeks and months is a huge unlock to the business. So that's what we're doing at Datafold with migrations. You can find us on the conference floor and chat about this. We also are giving out fresh coconuts because we need to hydrate those data pipelines, right? Cool. Questions?
Can you go back 2 slides back? Yes. The SQL translator. So do you subject all your SQL code to the SQL translator? And what does it take to build the right dbt models?
Do we subject all the code to SQL translator? And what does it take to build the right dbt models? So the way this works is we take a project, which could be a DBT code base on some legacy warehouse, or it could be a legacy code base without DBT, like store procedures, or it could be just plain scripts, SQL scripts. And then for every model, we run this process, right? So we run the translation, and then we do the reconciliation, and then we repeat it over and over again. Now, how do we know that we packaged it into DBT well? Well, if you have an existing DBT project, then we maintain the same structure, the same patterns. We even translate all your macros and packages that you use from the legacy dialect into new dialect, which we've done for Sevdesk. If you're not using DBT, then the question is, how do we make sure that we package this in DBT the right way? So we have constructs that basically allow us, when we run the translation, to use the latest best practices from DBT. So mostly it checks out and builds you the project that you can just run with. But obviously, because we're going from hundreds of non-DBT code to hundreds of models of DBT code, some fine-tuning after the migration can be done. But the most important thing is we give you the code base that just runs to the point of the advantages of lift and shift. So it runs, it gives you the same data, which is the most important thing. Obviously, it's not optimal. It's not maybe using some of the patterns that you want to leverage, maybe not the most cost-effective code, but then you have all the time to get it to the point that you want once you're ready on the new platform.
What if you're already halfway through and want to have read what you got here? Can you augment what I've already done?
Great question. So what if we are halfway through? Can this be helpful? I think so. I mean, ultimately, if you have, I don't know, how many models do you have? OK, let's say 1,000 models, and you migrate to 500. You can give us the remaining 500, and we'll just work on them. Or if we actually met one company that said, you know what? We will have our engineers migrate every model by hand because we want them to learn DBT the hard way. I'm like, cool. And so they're using us only for the validation with diff. So making sure that once they are translated, they can prove the parity. So that's also an option if you already underway with the code.
Yeah, I'm interested in the boundary between lift and shift and re-architecture. Like you talk about stored procedure use cases, and I've got a giant spaghetti ball of stored procedures.
Yeah.
Like how far can you intervene in that kind of structure with all those side effects and still be a lift and shift? Like how far can you push that? Like a DBT project doesn't even really move the same.
Yes, that's a great question. So in general, the input to this process, beside the code, is like the general pattern that you use. Like, OK, I'm using these schemas. I want that, those schemas, which is configurable in like a YAML-esque interface. And as part of that, you can also tell us what kind of patterns do you want to use. So for example, I have these sort of procedures that look like that, and they build like data incrementally. Do I want to translate them into incremental model, or do I want to translate them into like a full rebuild model? So some of these patterns can be supplied in this process. But ultimately, it still comes down to building, kind of decomposing it into simple blocks. Like, OK, I see that this procedure builds 3 tables and then does a bunch of other things. OK, let's throw the other things away if they're not actually touching the data. Take those 3 tables, turn them into DBT, one DBT model each, and then have that being the result of the translation. Ultimately, we look at like what's built in terms of the final views or tables in the legacy system and try to match it as close as possible in the new system with any kind of ad hoc interventions as needed. Ultimately, there's always a long tail of things. Like typically, the translation from like 0 to 90% takes like 10 hours to run. But then you have these 10% that you spend maybe like a week or 2, and those basically are when we look at the code and we see like, OK, what's not matching? Sometimes it's a hashing function. Hashing function on Snowflake and Redshift produce different hashes. And if you use that for creating surrogate primary keys, then, well, you just can't reach parity. So you have to basically do an override and say, well, I'm just going to say that this is OK, right? And the same for stored procedures. If we can't really match things one-to-one, then we do like a manual override, which is under the hood, just like a prompt to the model of what it should do, or any kind of like override in terms of what's considered on par versus not.
The step that says new SQL DBT models, does that take care of the refactoring step as well when you're changing your hard-coded froms
Correct, yeah. So basically all the targets and sources are automatically translated into dbt.
What kind of access do you need from an internal tools perspective?
So pretty much the same access that dbt would have itself, dbt cloud. So connection to the source database, connection to the target database, plus we typically install like a GitHub or GitLab app to ingest the code. And if you have a very strict compliance needs, we can deploy in VPC. We can also have like an EU SaaS deployment, so we are SOC 2 GDPR HIPAA compliant.
The interesting discrepancies kind of sounds like materialize and compute. So if you're doing this iteratively, how do you make sure that those costs don't skyrocket?
Great question. So part of this process is figuring out what data we use for testing. And we're not using entire data set because just like you say, it's just a lot of data to move, and it's not really practical because it's not needed. So we actually, as part of doing this, build a representative sampled environment. So we take samples of different tables. We also try to do it in a clever way. It's hard, but do it in a way that retains as much as possible the referential integrity, so we can also validate that. And then we're just using the samples to do the validation. So this process, when we say it's validated using sample data. But then the second process, second stage, typically what we do with customers is give them the code base, then they deploy it, and then they use this kind of cross-database diff to compare the final output production scale between the new system and the legacy system for like final user acceptance testing.
Is there a situation where you would refactor or you always team with on shift?
So sometimes, just like we discussed, some refactoring is needed because things just cannot be translated as is, right? But we're not trying to do any other types of refactoring on the go. I think as we develop this product, we probably may come up with like seeing patterns like, oh, when we see this query, we should translate it into that construct so that on Snowflake it runs faster. But right now, we're really optimizing for lift and shift. But if you have any kind of overrides, like you say, well, these tables were built in this schema, or we're using that function, but instead we should be using this function, or we were operating with like second precision, but now we want timestamps in microsecond precision, those overrides are quite easy to implement. Or if you say like, okay, we need to like correct how this particular column is computed, but I would say those are more, not exceptions, but we try not to really do as much of those because that makes the process harder, the initial translation.
Is it fair to say a majority of the migrations you work with or are doing, it's like a percentage of like 95% lift and shift and then the 5% refactoring? Whenever you run into something that doesn't run on that target platform exactly the same as your legacy system.
Yeah, I would say the lift and shift is like the North Star. But yes, you always, like I said, getting to 90% is very fast with this process. And then remaining, then extra 5% is probably a few days of work, just like edges here and there. And then the final 5% is where you have these like small numbers, weird things like one-offs that require a little bit more manual intervention.
Does this agent work with Informatica as well if you have to migrate out of
It should. We have not done a project with Informatica specifically, but I believe that Informatica translates into a DSL, right? Like compiles into like DSL, so it should be possible. Yeah.
Have you come across a situation where, I guess in the simple case, you've got a load of queries that were running on the old system to materialize a bunch of tables that were consumed by a bunch of BI tools, and then you want to move lift and shift that over to your system. In the case that I'm working on, actually all those queries are within the BI tool, so they're not really materializing tables, they're just running on the fly, and there are like different versions of the queries that are really doing the same thing in lots of different reports, but they're not actually the same, they're like very slightly different. How would you, I feel like the first job would be actually unpicking all of that and trying to work out what are you actually even trying to recreate in the new system. I'm not even sure what lift and shift quite would really be there. Have you been through a situation
Yes, if I understand the challenge correctly, basically lots of queries embedded in BI tool, a lot of repetitive code with maybe like some filters and some like structures, aggregations different. Like how do you move like that code base? So we actually have a few prospect customers that have done this, and most migrations don't involve just moving the actual code into dbt. It also involves moving the consumption layer as well. And I would say typically what we do is we first make sure we move all the materialized stuff, like all your base layers, all the base transformations. Then you have this like long tail of BI stuff. And with BI, it really depends on what kind of BI tool you use. Like, is it Looker with LookML? Then there's like one approach of translating, and it's fairly lightweight because it's like pretty minimal SQL. Or if it's something like, I don't know, Mode or other kind of report-heavy tools where there's a ton of embedded SQL or metabase. So in those kind of tools, typically we take the code base and then we work with the customer and we say like, okay, what do you want to do? Do you want to just translate all those queries and then copy paste them back? Or do you want to maybe move them into dbt and have them be like a layer of tables? And that is kind of where it becomes a bit more of an ad hoc process. But we can apply pretty much the same paradigm in terms of if I know what the query, input query and an output query is, I can easily translate it. And then if you have a lot of redundant stuff, maybe you just try to come up with a kind of a generalization that allows you to build like a one base model instead of like 10 versions of the same query.
Question, what are the true costs of the migration? What are the true costs for this migration? Do you have licensing for data diff as well as invocation to the foundational models, like OpenAI and those type of models? What are the true costs?
Yeah, so how much does it cost? So it's a SaaS application. So pretty much you buy us as a vendor, and then you can do the migration, and then a lot of our customers keep using us for other things like CI and data monitoring, lineage, and other tools. Typically, pricing works per asset, like depending on what you're migrating from and to and the number of models, we give you the price of how much would it cost to migrate. But usually it comes down to like 1/5, 1/10, 1/20th of what it would cost to do it manually with people, just because it's way more scalable. And in terms of the cost for actually LLM inference, we don't like pass it along, we just eat it. But it's actually not that high relative to other things. Relative to how much it would cost a human to do, it's minuscule. Possible to do at POC, it depends, because a lot of the times it's like all or nothing. But if you have a very big project, yep, it's possible to do like, okay, let's do like a subset of models. Yes?
Who ends up with rights to the code or view of the code?
Sorry, yeah, good.
So the actual code, you're passing it through an LLM somewhere?
Yep.
And you probably have access to the code?
Oh, who sees it? Yep.
Who sees it? And is anybody getting rights from it?
Correct. So the code is only exposed to cloud provider. So we use native LLM inference in clouds. Like for example, if you use our SaaS, it's AWS Bedrock. So we don't send data to like OpenAI or anyone. And Bedrock does not actually use whatever inference you do to train the model. So it doesn't leak anywhere. So it's actually very good in terms of the compliance. And in terms of who sees it in terms of people, typically that is like a forward deployed engineer on Datafold side. But overall, the exposure is less than if you would hire a consultant firm, because they would have dozens of people who would have access, and in our case, it's like 1 or 2 people who just oversee the migration process.
So we can specify if I want to build a star schema or a snowflake schema, data vault architecture, something like that.
Well, that's where it gets from the lift and shift to architect territory, right? You can specify some things, but we do not recommend changing the schemas and the layout of your models, because then it becomes very hard to reconcile and you have to teach the business like, okay, the data works a different way. We recommend doing it like lift and shift, and then you can always put like a silver or gold layer on top, right? That just transforms data you want it if you really want to. Yes?
Yeah, is there a requirement for the source database, schemas, and table names to be identical across systems?
Not necessarily. If they're not identical, we just need the mapping. So for example, in the old system, it was called something scary, like B2S2. And then in the new system, it's called marketing. And that's it, yeah. Just like a YAML configuration.
So there are a lot of stored procedures that do like insert and update statements.
Yeah.
Like multiple of them. And you can translate that all into an actual model.
Yes, sometimes it's probably, if it's like an update, probably would be something like an incremental model. But we try to simplify it as much as possible so that we don't mess with the mutation of models, because that's where things get messy. And I know that DBT is also now building like a more robust framework for how to deal with incrementality to solve that as well. But yeah, we try to make things as simple as possible. Sometimes there cannot be if the stored procedure is very, very complex, but that's kind of where we are in this long tail. Yeah. Great questions, everyone. Awesome. I think we're out of time. Thanks a lot. Good luck. And I'm going to be on the floor at our booth if you want to chat more.